go into a discussion. This is what we always do. We talk about the current weather, and then we'll talk about the forecast. And the current weather today, of course, will involve a fairly lengthy discussion about aspects of Hurricane Dorian. And it's now got its eye on the maritime provinces in Canada. So it's going to be a major event in Nova Scotia, Prince Edward Island, and parts of Newfoundland. And we're going to talk a little bit about that, both from a perspective of looking at the structure currently, as well as the forecast structure into the future. So it'll be quite an interesting discussion.
John, is there a class after this in this room?
I don't know. Let's check the wall.
I don't think there is.
No, there is nothing scheduled after this.
So if we're discussing the stuff, I mean, for my class,
Yeah.
we can go over, because this is part of my class, so.
Yeah, you can certainly stay here. Yeah, there's nobody kicking you out. Yeah,
Yeah.
yeah. You
Well,
can
maybe we
certainly-
should, maybe we'll do that, we'll just stay here.
Okay.
Make sure you let Sue know so it's marked on the.
Yeah, that way no one will come in doing
Yeah.
yoga at 1:30.
Okay.
No, that's what happens in this room usually. Yeah, that's true. All right, okay, so let's
Okay,
start with
thank you,
Professor
John.
Michael Morgan.
Thank you, John. So this is going to be really brief, just to intro, particularly for those of you that aren't familiar with sort of the Wisconsin climate, or certainly the Madison climate. What's shown on this chart, which comes from the Office of the State Climatologist, which is located on the 13th floor of our building, shows the maximum and minimum temperatures averaged over a 30-year period from 1981 to 2010. This 30-year average is a moving average that's done every decade. They update it, and that's a standard by the World Meteorological Organization. Years ago came up with this sort of standard for reporting climate data, given that climate is not a stationary feature. It changes over time, and so you want to have the appropriate background. So this is relative to this 30-year period. The maximum temperature at Madison, the minimum temperature at Madison, and then these black bars right here show the range of temperature for individual dates during the course of the year. It's kind of tricky to pick out a particular time of the year. This looks like it gets almost to the end of August or so. But I just wanted to sort of look at this and kind of figure out what's typical or kind of expected this time of year. I guess we're probably looking at temperatures in the mid-70s for highs, lows in the low to middle 50s. On average is what's been reported here in Madison over the last, over that 30-year period that's indicated right here. Over the summer, you may recall that brief period in early and mid-July, or most of July, being well above normal temperature-wise, preceded by a June that was really chilly, and we'll see also wet. Temperatures well below normal in June, and then by the time we turn into early July, things really jumping up to becoming well above normal. In the last few weeks, we've been maybe slightly above normal for a couple of days, but generally, this has been a below normal period for us over the last few weeks. And we'll see as we go into the forecast just how that's going to evolve. But this just gives you a sense of how things typically evolve here in the Madison area. You can get these pages again from the Office of the State Climatologist. They have them for 7 cities around the state of Wisconsin.
I think it's interesting, at the peak of our warmth in the middle of July, you notice the minimum temperatures are way above the normal for their days. There's a whole bunch of, blank, no gray spots there.
Right.
And that testifies to the high humidity that I remember. It was hard to get below 70 degrees at that period of time. And also, that's the signal of climate change in the summertime around here, is that the overnight lows are higher.
That's right. So, and as we've had some relatively pleasant weather and sort of cooler temperatures, but also lower dew points, we've also gotten into this period that it's cooler for the highs, but also the daytime. The nighttime lows are actually lower. It's probably because we have less water vapor.
Yeah.
The temperature's not
Also
so
point out that, remember that winter.
Yeah.
Yeah,
It started out okay.
Yeah, let's forget this, right?
It was 2 winters in a row.
But the interesting thing, I think, about the winter
Yeah.
is that dropped us at such a low minimum there, and then we got way down there, close to minus 30. Notice all the dead trees in town.
Yeah.
And that's because we've not seen temperatures like that for a long time.
About
And
2
this was
decades.
just too much stress for trees that have grown. Many of them are zone 5 trees, but this was a zone 3 winter.
Yeah. So the
And
vascular systems can't
Zone
deal.
3, agricultural zone 3, does not allow a lot of the foliage that's in Madison. So that's why so many dead trees and other things, other perennial plants just died last winter.
Right. So the fruit trees that we have in our yards, we were talking
Yeah.
about that earlier. I have a peach tree I've had for just about 20 years or so. Produces lots of fruit, but then this year, no fruit, and also a significant part of it just died off.
Yeah.
I would also say that we only had like one good snowstorm before it got super, super cold in February, so we may not have been able to insulate the ground as well.
Yeah, that's a good point.
That's where we're really getting affected.
That's an excellent point. So yeah, so not having the ground insulated with snow cover is certainly gonna be another factor when we get these cold outbreaks that can keep us, that can really damage root structures and things of that sort. So we'll see if we, repeat this next year, but as Chris Tripley was saying, you remember this, but I just sort of blanked out of my mind. I didn't even see it when I was looking at this map, this chart just a few seconds ago. Let's click back and go to the precipitation. We'll go for the calendar year, not the water year, so that's a little bit further down here. So, and again, this tells the story that we've had most of this year, just all of this year, in fact, or just about all this year. Above normal precipitation, we're running above normal. This is, again, the precipitation on average for each calendar day all the way to the end of the year. Normally we get about, on average, we get about 34, 35 inches of precipitation, liquid precipitation, equivalent precipitation during the course of a year. And we are, already at 30, so you can see we're well above normal at this stage. And that's likely to continue, as we'll see when we get into the forecast. So a wet spring, a cool spring, followed by a relatively wet summer. I wasn't here during this period, but it looks like there was at least one big rain event during that time period that, even though it was still warmer than normal, we stayed raining, probably being convective of that, I imagine, on that day. So, wet and warm for the last part of the summer. We'll go back one thing, and just for the folks in the class, we'll look at the sort of, this is a map that shows the hazards expected over the United States for the next, I believe this is 8 to 14 days. Yeah, yeah. All right, and so we can see here, actually let's go to 3 to 7 first, please. So it's color-coded here, the possibility of heavy rain in the northern plains and the upper Midwest, also northern Missouri. Then in the southern part of the United States, this is over the next 3 to 7 days, we're looking for much above normal temperatures. Severe drought conditions in parts of Texas as well as in the Pacific Northwest. Maybe some flooding in South Dakota and then along the east coast of the United States from the passage of the tropical cyclone Dorian. Flooding expected even in the wake of this storm. This is 3 to 7 days out. Lots of rain, freshwater flooding, and those rivers are now draining back into the ocean, and so it's going to take some time for that flooding to ease off. If we now then go to the 8 to 14 day period, you can see the things that are going to be of interest of the United States. Again, heat building, or the potential for much above normal temperatures in the southern part of the United States, and then possibility of some heavy precipitation or slight risk of heavy precipitation over the Great Plains and the upper Midwest. So that's something, again, we've been above normal, and this is sort of pretending that we're probably going to be in a pattern that's going to keep us wet. And we'll look a little bit at that in the forecast in a few moments. But at this point, I'll turn it over to John to talk about the current weather, current conditions, and a diagnosis of some interesting phenomena.
It just occurred to me, if you like to use coloring books and you have a lot of Sharpies around, the Weather Service and the Climate Prediction Center have tons of maps you could draw on.
Right.
You know, people might start to do that in high positions.
But you should not be, it's illegal to present that as a forecast.
That's right, yeah. But I just thought, if you don't like the drought condition in the Midwest, draw it somewhere else. You can do whatever you want on those maps. I want to show you a few things about the hurricane structure currently and some interesting responses by the mid-latitude atmosphere to its presence. And alerted by talking about this yesterday in our senior cyclone class, 452. So let's start, Pete. First, I know you prepared some movies. I don't want to just not use those for this week, so if you've got them ready, let's look at them first, because that'll be interesting in and of itself, and it's a perfect backdrop for what I want to talk about next.
If I could for just a second, John.
Yeah.
Let's look this way. I want to take a picture. This is the first time you had a weather watch in which you've used the word hurricane in the first sentence. So that's a special time to.
I guess that's noteworthy.
Yeah. Done.
Okay, that's exciting.
This
So
is
that'll be all over the
starting
map.
August 28th. Dorian is down here in the corner.
Okay, yeah, and here's Cuba. You can't see. There's Cuba,
Puerto Rico is
Florida, the Bahamas, and there's
Right there.
Haiti, Dominican Republic, and
Puerto
Puerto
Rico
Rico
is. So
is.
this is the day that
right
it went
there.
northeast of Puerto Rico.
Yeah, which was lucky.
Yeah. It's a
Well,
little hard
people
to see
down
the
there are
outlines
still
in there.
recovering from 2 years ago, so that's good.
This is a pretty long loop, it goes like 2.5 minutes, it's every 5 minutes for like a week, so.
Took a long time for the eye to emerge in the infrared. I think there were times where in the visible you could see it kind of beginning to show up, but not really so obviously in the infrared, and that's what we're looking at here is the infrared. So sooner or later it's going to show up. I think it's coming right about now.
Yeah.
And there's been all sorts of discussion in the last couple of days among people interested in this stuff. There's a lot of biological
There's, yeah.
activity that goes on in the eye. There's birds that get stranded in it and so on. And so there's a beautiful eye. And it's really, I have to say, it's really stunning when these things finally show up. I remember especially the Katrina movie, where it was coming through the Gulf of Mexico, over the Straits of Florida, and it seemed like someone had missed a whole bunch of images because suddenly there was this coherent, absolutely unperturbable eye out of what looked like chaos before. So here it is, marching across, here it comes across the Bahama Islands.
Right there.
And I think that's Abaco Island, right? The
Yeah.
Grand Bahama's this one,
Right.
and it's gonna get hammered right over the Grand Bahama.
Notice how slowly it's moving.
Look at that, at 1.1 mile per hour motion.
I think it sat for like 18 hours.
Yeah, and there's, I guess the death toll continues to rise daily. It was 7 at one point, then at 20. I just know it's gonna end up over 1,000, probably thousands by the time they're done. I mean, there's
Yeah.
no place to go.
This morning they're
That's the point
reporting
out.
that there's still hundreds, if not thousands, that are still missing, so.
Yeah, so it's, it's incredible.
Another
Yes.
tropical disturbance moving into northern Mexico and the western
Oh,
part
yeah,
of that.
yeah. So then, after it made landfall and stayed an extended visit in the Bahamas, it kind of moved slowly northward along the Florida coast, lost a little bit of its organization, but it gains it back, as you'll see.
Sorry, John, if I could comment,
Yeah.
the loss of organization was in part due to the fact that when these tropical cyclones sit over a particular area, the Bahamas aren't, the Atlantic over in the Bahamas isn't particularly deep, and so it was able to upwell a lot of cold water, and tropical cyclones like that warm surface to be over, over 26 degrees Celsius, and it actually churned up upwelled lots of chilly water, and so
Yeah.
that killed it, and the lower part of the circulation got disrupted. It wasn't until it actually began moving away from that over the Gulf Stream and toward the U.S. that it began to recover somewhat.
Yeah. And as you're saying that, you might have noticed in the last several images, we can't run it again, we won't have time to do it again, but in the last several images, the cloud presentation starts to look a little asymmetric. It looks like quite a bit more cloudiness spewing to the north and northeast as opposed to the south. And there's a good reason for that, and it leads directly to what I'm going to talk about for some of the current weather discussion now. Before I do that, let's go over a broad overview of the current weather. And so let's go to our,
First tab.
let's do maybe the current satellite over the continental U.S. The best place to start. Not the color, I don't like the color. It's fake.
The color is.
It's fake. All right, so there's a couple of really fantastic, it's called false color imaging. I mean, Brad, it's fake, isn't it?
No green band.
Yeah, see, there you go.
But
Okay,
there's, whatever.
I don't know what that is. Maybe he said yes or no. All right, so there's a couple of really big features here on this map that are worthy of note. One is this really monster extratropical cyclone that's in the southern Labrador Sea. This has been an impressive disturbance. We'll see some other characteristics of this a little bit later, but some of them are this cloud streak, this cloud mass south of Greenland all the way down to about the latitude of the wreck of the Titanic, and then there's the center of the circulation in the Labrador Sea. There's Dorian, and you can see it's an asymmetric cloud structure. It's much of the cloudiness now spewing rapidly to the north and east, and so keep in mind where that boundary is, right over New England through about central southern Pennsylvania. That's where we're going to see an interesting feature that's worthy of some side discussion. And there's Dorian, herself, off the coast, looking again stronger. It's going to now move out of tropical warm waters. It's no longer going to be over waters that are 26, 27 degrees C. It's spent a good long time over them, but it's still an impressive circulation. It still has a discernible eye at that latitude. So it's going to, looks like the forecast currently is to bring it right to the east of the island counties of Massachusetts, just about dead on to the south coast of Nova Scotia into Prince Edward Island and parts of Newfoundland. They're going to get some really strong winds here, gusting to 100 kilometers per hour in Charlottetown tomorrow night. That's the forecast from the Canadian Environment Canada. And so there's tropical storm warnings up over all of this part of the maritime provinces. reminds me of Hurricane Juan, which was September 6th and 7th of 89 or 98, I guess. And that was a devastating blow in Halifax and other places in Nova Scotia. So that's coming for the Maritimes. Meanwhile, we're in line for one after another sort of disturbances in the northwesterly flow. And you'll see that's more obvious when we look away from the cloudiness and start to look at the 500 millibar maps. Each one of these cloud masses, poorly organized though they may appear, are actually connected to well-established upper disturbances. And this looks like what you get in January and February. One little Alberta clip of snowstorm after another, 2 or 3 inches of dry, powdery snow. But here it is early September, and we're in that kind of a regime, which is nice because it keeps the humidity low. And when you're coming to work wearing a tie and a jacket every day, you don't want it to be summertime. You like it to feel fall-like. So some of us have a predilection for that kind of weather. I'm one of them. So I really like that. And then across the rest of the United States, pretty clear everywhere. There's another cyclone. Is this Juliet? I think this is tropical storm Juliet. So that's off the coast of Baja, California. That's an impressive disturbance as well. I think it was Category 1 yesterday when we looked at it in the afternoon. I don't think it's gotten any stronger, but I'm not sure of that. Okay. And then there's a couple of other ill-defined X's out here. The Hurricane Center likes to put X's all over the Atlantic map. We don't do that with extratropical cyclones because they'd be all over the place. There's so many of them. So anyway, that's what it looks like broadly across the continental United States.
No, just go back to that image for a second, Pete. Another point to make about this northwesterly flow. It's interesting that about 2 weeks ago, 2.5 weeks ago, we were talking about. I was sort of looking at you'll see folks that come to Weather Watch regularly. I like to look far out into the future in terms of forecast, 2, 3, 4 weeks out. And the forecast about 2 or 3 weeks ago were for the flow, that northwest flow to be over us, but to be even further to the southwest. So it would actually be probably 10 or 15 degrees colder than or cooler than we are right now. And it's actually what's actually evolved is something that's still a northwesterly flow, but the main jet is much further to the north, so we don't get the super cold weather.
In fact, even was it this morning or yesterday afternoon, you could feel the humidity rise again, and it was unusual in the sense that if you had a whole bunch of storms moving to your south along a jet, you'd never really get that northward surge. It lasted 12 hours. It's gone now. But it was there for a short period of time. You could feel that dew point get above 60 or 63, and now it's gone back down. So, and that's testimony to exactly where the jet axis is. It's not quite to our south. It's over us or to our north and east. Okay, let's take a look at the radar across the country, and then we'll take a look at the surface map. And then I want to show you some special things that I've prepared. So here's Dorian. Even with the Hatteras radars is tracking it. I suppose probably Wallops Island's got an eye on it now too in this mosaic. But you can still see a beautiful eye wall. Convection is not as intense, of course, as it was in Bahama, but it's still there and well put together. And then precipitation bands extending much more dramatically and exaggeratedly towards the north and east. For reasons that we'll talk about as we get moving into the discussion. So the impacts are now beginning to be felt along all of Long Island, Manhattan, Long Island Sound, the island counties in Massachusetts, and the middle Atlantic states.
Can I point out that
interesting.
The reason the storm looks like a little circle and it's so isolated is because it's further to the east from where the radar is than it has been before. So the radar beam slants up on an angle, so it's doing, and the storm is just only catching the very upper levels of the storm.
Oh, yeah,
it's missing the lower part.
Yeah.
And so that's why it looks like this isolated circle, because that's where it's very deep and gets up very high.
Yeah.
And it doesn't mean that it's just as high to the east over there where you see all those clouds. It just means the radar beam is lower there.
Yeah. So this still is probably more intense convection in reality. And there's some on the eastern side of it as well. Yeah, that more looks like this probably.
Right.
Yeah, that's right. Yeah, because those radar beams are refracted upward, and so they have a very limited range.
Well, they're tilted upward.
Tilted upward, yeah. And, well, they refract too. So they're tilted at 0.25 degrees and they refract up too. So it's a double whammy. And here's some precipitation associated with wave number 1. And this gave us just a sprinkle maybe yesterday afternoon in some parts of the state, a little bit more than a sprinkle in the northern part of the state. And that's wave number 1, and wave number 2 is still in Canada, so the radar for our mosaic across the continental United States doesn't quite show it. And so there's another threat along parts of the Great Lakes later on from that. And then some widespread but not well organized precipitation. Some of it may be convective. We saw that it erupted over all the high terrain yesterday under fairly ridgy conditions, all the way from Baja, Mexico, up to the panhandle of Idaho. And so some of that northern portion of that is still active today at around, it's locally early, it's only 10 a.m., but it's nonetheless, there's some stuff going on. So it's not just diurnal heating, it's something beyond that.
Hey, John, I just wanted to emphasize a point you made. It's a very small one, but for those of you that haven't seen these images before, as John said, this is a mosaic of radars. So we've stitched together, or Pete stitched together all the radars, National Weather Service radars across the country and put them into one image. So this is not one device or one sensor doing all this. This is actually a collection of them all put together.
Yeah, all kinds of different massaging of the data to make it work, but it's a beautiful image. And this is probably the most, this particular kind of portrayal of meteorological data is the one that I think most people have the familiarity with now, operationally, around the country. You see it everywhere. You see it at Little League parks, you see it at football stadiums. Everybody says, oh, have you seen the radar? They have it on their phone. It's the first weather app they have, is a radar. Because everybody knows something about what it means, and that's good. I think that's a really
So, can
big
you
testimony
explain
to our field.
what that thing is moving down through northern Missouri?
This right here?
Yeah, what is that? like?
Probably not precipitation. I don't know that it's not. We'll go to the surface map to verify. So we'll keep an eye on places like the border between Indiana and Illinois, central Kansas. These radars can be turned on to higher and lower receiving power. So when they don't have much weather around, but there may be some other things of interest, maybe there's fog, maybe there's low clouds, they'll turn it on to a higher receiving power. And so you can start to see some things that are not really meteorologically as relevant as falling precipitation, but also of interest. Occasionally, even migrating flocks of birds will show up on a high power return on the radar.
In particular, in the humid area, there's lots of mosquitoes and insects.
And insects, yeah.
And what you're seeing is the front pushing south with the clearer air. And you're pushing kind of a front of bugs.
So
Yeah.
if you look at the true color image, there's smoke in that area.
Oh, is that right?
What you're seeing is the radar signature of smoke.
Oh, okay. It's
Where's that, over Kansas?
yeah, Kansas,
You can see that.
Missouri,
in the
Illinois.
image.
Yeah.
In the true color, does that mean the grayscale image, Brad, or?
The false,
Oh, the false one, okay, I didn't even notice
The
that.
one we were just
I
looking
didn't
at.
notice that.
Take a quick look.
So where are those fires,
Let's look at it.
where are they
closer.
based? I know there's
Those
products
are-
downstairs that actually show that.
there's been a lot of agricultural burning
Oh,
ahead of there you can see. the
oh
surge.
yeah, there you go.
There you go. Yep.
Greg's point about a surge of a different air mass, and Brad's point about the prior humid air mass having smoke in it is clearly evident in both cases. Very interesting. And the smoke is bound to be, how is it picked up on the radar? Just because it also has little water droplets around the smoke particles?
So,
And
yeah, that's agricultural burning, it's very, the black carbon swells, and so you're
Yeah.
able to pick it up on radar.
wow, really interesting. Okay.
It's one of the, you can't see all the aerosols on radar, but you can see smoke.
Yeah, how do you like that? And it's exactly where you'd say, based on putting both of the images together, so that's really interesting. Oh, look at this too. Didn't see this, the fog in the valleys in eastern Kentucky and parts of Tennessee. Look at that, morning fog, isn't that beautiful? That is neat.
And you told me you didn't like the false colors.
Well, you'd see that in the gray too.
You would, yeah.
You'd see that in the gray too.
Tropical cyclones, false color.
I just don't know what to believe. You know, we're in an era where it's a little bit valuable. If somebody tells me that this is a false color image, I'm not so excited about that. I like truth. All right, so, but anyway, there's a lot of truth in it, so you can see some good things there.
But of course, the black and white is also false. You're making up an image from radiance, and it's not black and white, it's just radiance. So,
Okay, so let me put it this way, it's more familiar. Let me put it that way. Yeah, it's more familiar, so that's a good point.
it's all false.
Nothing's true.
All right, class is dismissed. Okay, so let's take a look at a surface map, and then we'll go to the upper level charts, and that'll lead me to a short description of what I wanted to show you about some of the current structure here. So here's our continental surface map, continental United States. We're enjoying a nice day. It's overcast, but it's a low dew point, 56. Yesterday evening, I think we were well above 60, and I think that's shown by the fact that places just to our south are over 60 for the dew point. So 72 in St. Louis. Remember, we were seeing that northerly flow and then the smoke and the radar reflectivity kind of beginning about northern Missouri. Dew points rise rapidly from 63 into the low 70s
And a
in
wind
most
shift,
of the
too.
state. Sorry?
And a pretty evident wind shift in Missouri.
Yeah, that's right, down in this region anyway. And it's even more clear as you move across the region into Illinois and Indiana as well. So yeah, very humid air down to the south, and we're enjoying nice low dew points. And then uniformly in the mid-50s, a few occasionally lower spots, but broadly the same weather over much of the Great Lakes states, from one spot in it to any place else in the Great Lakes states today, with a little bit of light rain to the east. We saw that on the radar. Okay. Let's go to the East Coast and see what we can see off the coast. Unfortunately, nobody's taking obs in northeastern North Carolina. I suppose there's a good reason for that. Heavy rain at Norfolk, 20 knots. Light rain to the north in Salisbury, Maryland, and that's 15 knots. So those are about the strongest winds you see right along the coast. 20 here somewhere on the southern part of the Pamlico Sound, and 20 knots also down near Wilmington, North Carolina. They had stronger winds earlier, I'm sure of that.
That Norfolk op was really kind of dismal day, 74 over 72.
Yeah, 74 over 72, heavy rain. Where's the room for the water vapor in heavy rain at 74, 72? There's not 100% relative humidity. And then strong winds as well, probably gusting well into the 30s, maybe even 40.
I'm actually from Virginia Beach,
Yeah.
New York area. My mom sent me some videos this morning. The wind was definitely intense and rain.
Oh, is that right?
And they canceled school too for
Oh, really?
kids today. Yeah.
Okay. Is that a common thing for a hurricane?
It is because we get really bad flooding in my area.
Oh, yeah.
So they have to cancel school for the whole district. So it's a lot of people that move out of their neighborhoods and stuff.
Yeah. Oh, and then the other big thing in Norfolk is, what do they do with the fleet? Don't they always have to worry about that?
The military?
Yeah, do they put it out to sea?
So I'm not actually sure. My dad was actually a Marine for like 20 years, so
Yeah.
I'm sure he knows more about that.
Yeah.
I can ask him.
Yeah, I know there have been times where they've had to decide, should we get the fleet out of Norfolk Harbor? Or should we put it up the river or something like that? I mean, up the river doesn't do you much good because you're going, or up the sound because you're
Chesapeake Bay, yeah.
Chesapeake Bay, you've got the same exposure just about. That's really interesting. Yeah, I didn't know they canceled school, so they're on a high alert there in Norfolk.
It's mostly the flooding.
Yeah, okay.
And the flooding's become more prevalent in the last few years, right, because of climate
We
change.
get pretty severe flooding.
Yeah, wow, there you go, sea level rising. Okay, that's enough, let's go to the upper level super Pete's. And I want it, for the first time in a while, Pete, well, it won't stop there, I will eventually use a loop, I don't usually use them. Let's go to the 500 millibar map, if we can. So here's the continental scale 500 millibar map. For those who have not seen these maps before, the black lines are geopotential height lines. They're sort of the equivalent of isobars, but on a pressure surface about 5 kilometers above the ground, 5.5 kilometers above the ground in this case. The red lines are isotherms drawn every 5 degrees C. And so you get a picture, and then in green with the little wind bobs, these are actual observations taken at a variety of stations paid for by taxpayers to evaluate the weather and the threat for bad weather in Alabama. So here we have a nice picture of the flow at about 3 miles above the ground. And so here is what Hurricane Dorian presented itself as at 12Z, 7 a.m. this morning at 3 miles above the ground. Here's a little wave that's associated with the precipitation we saw in Michigan. And yesterday afternoon and evening in northern Wisconsin. That's storm number 1. And then this second bit of cloudiness we saw on the weather map, the satellite movie, north of Lake Winnipeg, northwest of it, is associated with this wave. You can see there's a little bit of a change in the flow direction, curvature, in both of those disturbances. And they're all embedded within a broad northwesterly flow on the western side of a broad upper trough. On the eastern side of that trough is this really intense minimum in geopotential height that's tied to the storm we saw on the satellite in the southern part of the Labrador Sea. And that's an impressive storm in a number of ways. On this map, it's most manifest as a really intense baroclinic zone. That is horizontal temperature contrast region where the red lines are close together. That is, I think, unusually intense for this time of year at this latitude. This looks more like an almost late autumn storm than a late summer storm. And so it's a pretty intense baroclinic zone. In the long run, the horizontal temperature contrast that's been engendered by that storm and then acted upon by the subsequent disturbances that come along in the mid-latitude flow will also have an impact on what happens with the remnants of Hurricane Dorian. And Hurricane Dorian is going to remain a hurricane, or at least a tropical storm, all the way up to the maritime provinces. And when it does that, when it finally gets there, it's going to stop to ingest this baroclinicity and begin the transition into an extratropical storm, still of great impact up in that location. So a lot of people are going to in the end, have been impacted by this storm.
I want to make a comment here because the storm is already completely connected in. You saw the primary band, as you were saying.
Yes, yeah, that's
Going
right.
to the north, the
That's right.
primary band is going to the north because it's plugged in to this wave train.
Yeah, that's
And
undoubtedly.
once the band went to the north, it was no longer a pure tropical storm.
Yeah,
Because when the band went to the south, it was connected into the tropics and the low spinning rate and all
Yeah.
that. I hesitate to use too many jargon terms, but to the north, it's connected into the cold air mass and the baroclinity. And it's actually, when we do the calculations from this, it's actually driving a lot of its energy from that as well. In other words, it spends energy pushing the outflow away. But when the outflow is literally being drawn up by positive vorticity advection and these things going on in the extratropics, that adds to the total energy of the overturning process of the tropical cyclone.
yeah.
And so now it's a hybrid system. And then later on, as you were saying, it starts to become hybrid even at low levels where it brings in the cold air at the low levels and then
Right.
and then that's all part of it as well.
Yeah, and you'll see, in fact, that is, that point right there is the one that kept me thinking about it staying as a hurricane all the way up to the Maritimes. You're right, it's not really any longer the same type of tropical storm as it was, but it's got a cigar-shaped PV tower right in the middle of it, all the way up to Nova
Yep.
Scotia. And so until and unless that cold air gets in, which it will inevitably do, it's gonna have that structure. And once it erodes, once that goes away, it's completely extratropical. But
That's
it's
right.
already got elements of extratropical interaction right now. That's no doubt about that. And so, let's go to 200 millibars peak. And let's do a movie at 200 millibars. Yeah. And we'll stop at it. We're not gonna do the whole thing, but I just wanna show you a couple things. Let's go back a couple images. No, don't give away the cat. Back. Okay, right here. Forward one more. This is, what was the 4th? That was Tuesday, right? Monday night?
No,
Okay.
Wednesday.
Wednesday night. No, Tuesday night.
Tuesday night.
Tuesday night,
Tuesday
okay.
before.
So Tuesday night, there's at 200 millibars, there's a local warm spot off the coast of Florida. That's where Dorian is, right? And it's got a little bit of a perturbation in the way, 12 and a half kilometers above sea level. Here's the polar jet and various features of the polar jet in the broad northwesterly flow. Here we are in the broad northwesterly flow that we're talking about now, several days subsequent to this. And the big storm that gets itself organized and is currently occupying southern Hudson Bay is tied to this first wave. This is now a couple of days old. Okay, let's step ahead one time. Okay, you see some little hint that there's a little bit of a wind speed maxima here off the coast on coastal Maryland. 75 knots at 200 millibars, not that much. Here's the hurricane moved a little bit further north. Let's go to the next time. This is now yesterday or Wednesday night, right? And so this expansive region of high wind speed seems to just come out of nowhere. Here's the hurricane. Here's the polar jet is still by itself to the north. This is a new feature entirely. Go back one image just so I can convince you of that. Not much there. Now go ahead. Boom. Now
John.
one more time.
Also, just make sure the people
Look at
understand that scale, how it will change in colors.
Oh yeah, sorry. I'm just talking without explaining. The gray is 70 knots. The next white interior is 90 knots, and then shaded here in purple is 110. If you get back to white again, you're at 130 and so on. So that's really a strong wind speed maximum. And it comes seemingly out of nowhere. Right? Go back 2 images, Pete. So there's nothing there. That's 70 knots. There's a little bit of 110 over Long Island. There's more over New England at 130 knots by the time we get to yesterday morning. And that's the time at which I want to show you some stuff in Viz 5D. Because we're only looking at one isobaric level here. Can we quickly go to the 300 millibar map? I'll keep my fingers where the strong jet is at 200 millibars. Let's see what it looks like at 300. Oh, we have to get...
No, I'll go back.
Okay.
Just move the map up.
But yeah, we gotta make sure the map's moving in the right place. Is it? Is that in the same place?
Oh, here.
That's about right, because it's over in Long Island. So there's no evidence at 300 millibars of any aspect of that jet. Maybe just a little bit. And then there's the polar jet that seems to be exposed, especially with the storm over Labrador Sea.
Could we go back to the 200 millibar map for a sec?
Yeah, 200.
Unless you're gonna keep
No,
talking.
I'm not gonna.
Okay.
No.
could just be this.
It's too bad it's not current, that's the only thing, it's easier to do this when it's current.
So if you go back a couple clicks, Pete, when it first, let's see, one more ahead. So one of the neat things about that, if you look carefully, those of you certainly in 452 are familiar with this, like the observations over like Dulles, Virginia.
Oh, yeah, down here.
You can see, if you sort of imagine drawing an isoclef of height, there's a strong ageostrophic component to the wind in parts of Virginia near the jet entrance region, which suggests that these air parcels are accelerating into the jet. And so, where does that ageostrophy come from? Part of it might be related to something from the hurricane, the tropical cyclone.
Here's where your hurricane is right at this time.
Yeah.
So now, if we can go to Viz 5D, I want to show you a few things, and then I'll be done. So that's a feature of interest. Caught my eye yesterday, and it's repeatable. It happens all the time in these types of events. So here's sea level pressure from Thursday morning's GFS model. So this is an analysis at 12Z. So there's the hurricane right off the southeast coast of South Carolina. Now let's put on the wind speed in this particular one, which was at 11.8 kilometers. This is the maximum jet speed we just saw at 200 millibars, nearly 12 kilometers high. And this is every 5 meters per second starting at 30. Can you see that okay? Should I turn some lights off?
Yeah.
Let's see if that helps. None of that helps. Isn't it amazing? There's only 3 of them, and it takes me all 3 possibilities to get the right one. Okay, so there's the 12 kilometer jet, 200 millibars. Look at the relationship that it has spatially to the tropical cyclone. It's really nice, right? That somewhere off to the north and east is where this jet resides at very high elevation, 12 kilometers above sea level, and there's the tropical cyclone. Speed prime is at 8.7 kilometers, and that's the maximum. We'll take the sea level pressure off, I guess, Pete. It makes it a little bit easier to see these things. That's the wind speed maximum of the polar jet. And so the next thing I wanted to do is take a vertical cross-section through this thing, right like that, perpendicular to both jets. And I do that with speed cross-section, I think. Yeah. And then we can flip that up, and you get an idea what this thing looks like. There's definitely 2 distinct jet cores. There's a 50 meter per second jet with the outflow from the tropical cyclone at 12 kilometers, and down here at about 9 kilometers is the polar jet, and that's at 20, 30, 40, 50 also. Okay, so they're both 50 meter per second. Let's put potential temperature on there and see what that looks like. We can maybe take these horizontal ones off so that it's just a little less flooded. So here's what the potential temperature structure looks like every 3 degrees. So for the polar jet core, there's a, not a tremendously strong upper baroclinic zone, but there's a broad baroclinic zone, almost looks like a composite of 100 different polar jets. And then this outflow jet also has some baroclinicity in the upper troposphere associated with it, which is quite dramatic. And then there's a wide separation of isotropes on the anticyclonic shear side of that outflow jet. Quite a bit of the air coming out of the tropical cyclone is at these kinds of theta E's, 345 to 355. That's where all that air is going. And it's pushing all these theta surfaces apart. And so you're getting all this change in the upper troposphere as a consequence of that. If we put the PV on top, this is potential vorticity, one way to think about how the atmosphere is structured. And maybe we'll take theta off this time. Can we take the theta off? Yeah. So you get a really nice sense of what's going on. Here's a tropical tropopause height. Remember, this was at 12 kilometers. This is like 15. Then there's a step down to the outflow jet. Then there's another step down to the polar jet. And again, this looks exactly like the very old now, 60 plus years old composite by Defant and Taba, which shows that the jet really has, the tropopause has 3 different steps to it. 1, 2, and 3. And it's a beautiful picture of that. Concocted in this case directly by the outflow of a tropical cyclone. And so let me show you this next thing. We'll go to the top view again. I want to make sure I don't forget anything that I had to show you. If I did, it wasn't the most important. Let's take a look. Let's look at theta E in this cross section. I want to do that.
Hey, John, as that's coming up, you didn't by chance do any trajectories, did you?
I did. Yes, I did. So here's theta E with the jet speed and the PV on there. So the theta E reflects the same baroclinicity in the middle troposphere and much more intense near the ground. But look at how much more intense it is in vicinity of the outflow jet because there's so much very high theta E somewhere in the immediate outflow of the tropical cyclone. These are not tropical cyclone theta E's, they're way too low. But the baroclinic zone that emanates from 12 kilometers down to about 4 is baroclinic moisture zone is tied directly to the edge, the sort of poleward edge of where that thing has been pushing. And it's really nice to see how this all works together in structure and not in any dynamics. I didn't look at the dynamics. Let's go to the top view again, Pete. And I'm bound to be making a mistake here. Let's put the sea level pressure in there and take the cross sections off for the time being. And then trajectory, I have a yellow trajectory, so it's I think number 2, is that right? Yeah, and then let's just animate that. So I'm starting these trajectories right near the sea level in the middle of the tropical cyclone. See where they go. They spiral up and look where they head, straight out along the direction of where that jet is. Okay. And then that's interesting horizontally, but it's better if you look in the vertical. So let's tilt this up, but don't stay in trajectory mode. So look at that. There's the vertical view. So these are air parcels coming straight up through the eye wall, or in the vicinity of it anyway, spiraling around as they go, and then finally they're released to the north and east. Not all at one elevation, but those elevations coincide, at least the top elevation coincides with that extreme jet that we saw at 12 kilometers.
So the interesting question here is, that I know the answer to, is the jet stream has a lot of energy, and apparently is deriving its energy from the tropical cyclone. What energy was that at the ground that it's bringing? Where is it getting that energy? Is it latent heat?
Well, let's see.
Is it from the condensation and latent heat?
This is a good question. This is the one that I remember we used to argue about this all the time, Michael, when you first came to Wisconsin. I didn't understand this. I'm not sure I do now. I know though that when this air mass here, the tropical air mass, has low potential vorticity, poor stratification. It's forced upward by the circulation of the storm, the vertical circulation. It tilts the tropopause. And once you tilt the tropopause, you have a tremendous ability to increase the horizontal wind speed. And so how that exactly answers your question about energy transformation, it has elements of a baroclinic energy transformation, and it has elements of, well, I guess if I had to put all my eggs in one basket, that's what I'd say. It's baroclinic energy conversion. You're tilting the tropopause by virtue of expulsion of low PV, high theta E air upward. I know that's not what you said,
I mean,
but how does that modify by what you
that's certainly part of it, particularly on the northern side. But the energy actually is derived from the fact that you're overturning the air mass. You're bringing it up from high pressure to low pressure. As it rises, it conserves, it maintains exactly what its entropy or equivalent potential temperature was. It maintains that exactly all the way up and into the outflow.
Yeah.
So it doesn't get new entropy. It's not a diabatic process exactly that's doing it. What's doing it is a conversion of pressure to geopotential, and the contrast of that geopotential with the lower geopotentials
to the north and east. Yeah, north and west.
is accelerating the flow. So the energy is coming out of a conversion of geopotential to kinetic energy.
Into a pressure gradient force.
Yeah, the fact that you lifted that air up and then converted it to kinetic
Oh, I
energy.
think we
So
have
is the
more
evidence for that then the strong agiostrophy south on the southern side of the jet near the entrance region?
Yeah, the agiostrophy is the conversion process. That's the agiostrophy. When you have to have agiostrophy to convert the potential energy to kinetic energy.
But it's got to be thermally direct, so it has to be an entrance region. That's why the jet is always downstream
No, it
of
is
the
the,
updraft.
I mean, the storm creates its own jet. So it's not just adding into a jet, it's forming.
Oh, no, I know, but
And it's going to form the jet, and it's going to be in the entrance region.
Yeah,
if it's doing
but it has to be. It
It has
isn't
to
just,
be,
it
yeah.
isn't just a coincidence.
That's a given.
It has to be.
That's a given.
Because that
By
circulation,
definition.
the only one that does the baroclinic conversion is thermally
Yeah.
direct. Yeah, I never thought of that before, that argument. That's a good argument. I like that. I had elements of it in my head, but not that last piece. So that's really good. So that's I think what's going on to drive this. Let's take a look now at, we'll stop it at 18 hours in the forecast, so 18Z, so that was, right about yesterday afternoon. And it'll go to the top. And I had some other stuff that I wanted to show just quickly. Let's look at speed prime. So I thought I had speed prime like that. Maybe just speed prime horizontal. What was that? Oh yeah, it's just different times. That's right. And then do speed at a different time. Oh yeah. Okay. So that's what I wanted to show. So here's this is 18.
18Z.
Oh no, it's got to be further along in the forecast. I'm trying to just keep marching ahead. I forget what which one it was exactly. Maybe it's 18 on Friday. It is 18 on
Must
Friday.
be
One
18
more.
today.
Yeah, that's the one I want, because I think that's the one I want. Let's go to cross-section theta prime. That'll give us an idea. No, it's not. Go a little further ahead, Pete. I must have had the wrong thing in mind. Keep going. Yeah, right there, I think is what I wanted to show. Yeah, that's it. I'm sorry. I had the wrong time in mind. So now we're on to Saturday, what, midday? So, by this time, everything that's going on in the northwesterly flow looks like both that very high elevation and a lower elevation is one piece of the jet, or one type of jet. Maybe the speed prime is the one to look at here. I can't remember if it's speed or speed prime. Let's try that. Yeah, that's it. Okay, and get theta off of there for the time being. Okay, so let's tilt this up when
Do you want
we're in
those-
Saturday afternoon.
Do you
Sorry.
want those trajectories off?
Yeah, they'll contaminate it. Yeah, that's right. So let's take a look at that structure. That's very different than what we saw before, right? There's just one jet core, and it's got an extraordinarily deep layer of shear associated with it on the north side of it. And if we put theta on top of that, you get a different picture of the potential temperature structure too. Pretty intense upper front, and then widespread isotopes. This is all uncontaminated by the tropical storm. And then look at this lower stratospheric front right in here where the horizontal temperature contrast is extraordinary above the jet core. And that's because you've put all of this jet in one vertical column, pretty much. So it's a very intense structure. And I think the PV also looks kind of interesting here. Maybe it's PV prime. Yeah, so it's a one step in the tropopause. This is the tropical tropopause way up above 12 kilometers. And then there's a polar tropopause and an undulation that comes down in the upper frontal region. So it's a vastly different structure on the upstream side of this upper trough than it is on the downstream tropical storm side. And it's quite interesting.
So-
and there's some subsidence that's driving these PV down the isotopes and so on, but I'm not going to show you that.
So, question I have is, if we focus on the first cross section that you were talking about, where you had the outflow jet
Yeah.
and what you termed the polar jet, just seeing that cross section and knowing nothing else about the synoptic situation, would you have called one as a tropical jet and the other the polar? And then knowing what the full map looks like in the origins of that, do you call it subtropical and polar, or is that polar one? Bring Greg into this. Is it also? Would it have been subtropical?
Yeah,
without having the one
okay,
south?
I'll answer first. I would say that we're far enough along into the late summer, early fall, that feature at 45 to 50 degrees north was the polar jet.
Okay.
That's my opinion. And I would have, upon looking at that cross-section, said, oh, look at this. We got a near juxtaposition of the subtropical and the polar jets. Knowing that the subtropical piece of it is clearly an artifact of the tropical cyclone, I would still maybe say that about it, but I'd have to have an amendment that says this looks like an outflow jet from the tropical cyclone, and not maybe part of the globe circling subtropical jet.
All right. If they were to have merged, would your software diagnosed it as a
Superposition.
Superposition.
Yeah, it would have.
does it have to have a certain length? I mean, I guess that's the other criteria that
No,
probably.
there's no length criteria.
Okay.
No, it's all if it's in one grid column. So it's a vanishingly small length. It's a space. It's a grid.
At one point,
Grid
okay.
point. Yeah. But we, with Zach Angelos, we wanted to look at ones that were strung together to really kind of consider them substantial events, not just individual grid points. So there, in the analysis of the data, you probably add that, but you don't have to do that in your identification.
Well, this is definitely what we normally would call a polar jet. But the question I have is, should we be calling polar jets just by the height or their origins? And was the origin of this jet stream, did it just develop in place in some kind of a contrast or a thermal gradient region in the extratropics? Is this what caused the jet? Or was the jet originally a subtropical jet that moved into the polar regions and morphed into what looks like a
Well,
polar jet?
That can happen in the summertime, as we both know. I agree
Yeah.
100%. I think this room, people in this room are the only ones who are confident in saying that. And the rest of the community has to get on board because it's definitely true.
Yeah.
However, I think this particular case, this feature emerged out of that broad northwesterly flow from higher and higher latitude the further back you go in time. I think this one has a uniquely polar origin. But I'm not prepared to say that it has no interaction with the ridginess over the western United States, along whose periphery there's a subtropical influence. So it's, I don't know that looking at just this picture. but I have a suspicion in this case that it's mostly a polar orange. That's my guess.
You know,
But
I just question,
It's in between the two heights that were obviously separated
you know,
at the prior
at
time.
upper levels, there's a gradual variation of solar heating, so there's less and less as you get north. And so there's really nothing to create a baroclinic process or a real strong baroclinic zone unless you have a polar a baroclinic cyclone or something to cause photogenesis and that to happen. So I think what we're saying, I think you agree with me, that the subtropical jets are what get in there and stir things up and actually cause this photogenesis process to take place, and it cascades into these polar jets.
Except that, I don't know, you're bringing up a really good point. I don't know at what time and by what mechanism suddenly these northwesterly flow events start to have substantial along flow temperature convection without much interaction with things from southern latitudes.
I've been
That
watching
can
this.
generate, but those can generate strong upper fronts and strong jet streams.
I've been watching this for the past month, and it's fascinating if you look at it over the month and how this comes across, because if you go back 1 month, there wasn't a single polar jet.
Yeah, that's right. No, you get to the beginning of August.
And
it's gone.
when you started seeing polar jets, they occurred at the edge of the tropical push. And they were very, very small, and they kept growing in intensity up until this point.
So maybe that's the first bit of rearranging the thermal field with respect to the mass
Yeah.
field that allows these internal dynamics at high latitudes to take over and start driving these things
Yeah.
internally as opposed to external. That could be. That could well
But
be.
you've got land-sea contrasts in Asia that are a big part of the energy for these things that are coming across the Pacific. It's not just driven by penetration of tropical features. You know, Asia's a big land, Asia's behavior is already, there's a baroclinicity just from land-sea contrast that's already there in Asia.
Yeah.
Well, you see that even in the summer, but you don't see the jets at all in the summer. They just completely disappear.
Yeah,
At least at a 40 meter per second level.
Yeah, they
I mean,
probably don't
they're probably at some very weak.
Right, and that land-sea contrast
Yeah.
difference may not extend all the way deep enough to,
Yeah,
to
it's
get
an
to
interesting question,
jet,
because
maybe.
I will say that observationally, it's definitely true that from mid-July to about mid-August, it's nowhere near as easy to find a polar jet. And then suddenly they become more plentiful. And all through the summer, the subtropical jet is evident.
I don't think it's
So-
suddenly, I just think it's at the threshold that you call it a polar jet. I think
Yeah, but I don't
think
know.
there's a continuous evolution upward in
Maybe the
intensity.
way to do it would be to look at the PV over that somehow,
Yeah.
to look at PV contours and structures all the way through the summer and into the early fall and see, oh yeah, these things are always there, but they're just not as tilted or they're not as this
Yeah.
or that, something like that. So anyway, that's what I wanted to show you, that the connection that seems to be, at least structurally, there's no dynamical diagnosis here yet. We can maybe do that, of the connection between the extratropics and the hurricane. But the Canadian Maritimes are gonna feel the effect of, oh, I wanted to show one more thing, Pete, that's definitely right. Let's go to the top. I gotta show you this, because we've already mentioned it. Right in, just show that I have PV, the surface, PV surface. Let's see what that looks like. What time are we at? Oh, that should have been saved.
What do you want, 2?
Yeah, 2. That's good enough. And then can we tilt it up? Look at that. That's the tropical cyclone. And that thing lasts all the way up to the maritime provinces. So that is what a tropical cyclone looks like in potential vorticity, a thin column of PV.
But notice it doesn't connect. There's
Well,
always a gap between it and the upper PV.
Yeah, because there's an erosion at the top of it. That kind of
Well,
pushes
it's not that,
same
it turns,
value up.
because of the way potential vorticity grows, it always becomes negative potential vorticity or zero at the top of the storm. So the storm doesn't feed into the potential vorticity budget, the positive potential vorticity budget of the upper air. It actually feeds into the negative potential vorticity budget, because that flips sign at the top.
Yeah, okay, yeah. But this is the thing that's gonna make its way all the way to Canada.
Yeah.
And stay like that, all the way up there. So it's gonna be a wild weekend in the Maritimes. Look at that. Incredible persistence. That's now over Nova Scotia. It's finally starting to connect itself
Oh, there it
to
goes.
the high
But
tropopause.
that's different, now it's a baroclinic system.
Yeah, that's right. And look where it is when it finally does that. Tilt it down a little bit, Pete. Look. It's over Labrador by the time that happens. Pretty amazing. Okay, thanks for your patience.
Thanks, Jeff.
So this is gonna be just a brief discussion. First, before we stop the discussion on the remnants, or what will soon to be the remnants of this hurricane, let's go to the Pivotal website for a moment. And just look at this, the structure of the tropical cyclone from a slightly different perspective, and also the jet that Professor Martin was just talking about. So I'd like to go to what they call dynamics here, and then the 2 PVU theta, please. And actually, let's we'll go to the 18Z tomorrow, so that'll be 30 hours, and we're looking at those last cross sections. And let's actually switch the model to the old GFS. There are 2 things I want to point out. First of all, look at how messy that was compared to this map. So the differences between these 2 maps. This is taking those ISO lines of potential vorticity Professor Martin was showing, or the ISO surfaces of potential vorticity, and just laying them out on a map. So you're looking at the potential temperature, this variable called theta, along a surface of constant potential vorticity. This is looking at the upper troposphere, effectively looking at the top of our atmosphere, but trying to imagine it's flat in terms of potential vorticity as a vertical coordinate. And you can see, going from the colder colors toward the warmer colors, you can actually see where there are fronts that actually form. It's along these upper fronts that we actually get our jet maximum, like we saw in the cross section. So you can see the strongest winds on this map are pretty much aligned right along the strongest horizontal temperature gradients on the, I'll say horizontal quotes, temperature gradients along this PV surface. And the warmth that you see here on this side of the front is, in part, the outflow from the tropical cyclone that we saw earlier. So if we go back and just step forward, go to 0 from the model initialization, when the cyclone's down here off of Cape Hatteras, and go forward in time, you see the creation of this front. You can see the gradients beginning to steepen right over parts of New York State. As you go from these white colors to these yellow colors pretty quickly. So this is all that temperature contrast that you see here is now pretty much a vertical wall, like you saw in the cross sections that Professor Martin was showing. Keep going ahead in this, and you can see sort of the forward leading edge of this upper wave that Professor Martin was talking about slows down because of the outflow and perhaps the diabatic erosion of PV just to its east. So it never quite makes it. It moves eastward, but it's slowly moving eastward. This is probably the outflow. This is probably where the cyclone is tomorrow morning. This warm area right here, where it's sort of depositing lots of its high theta air. So in fact, let's just look at the surface map for this time. This is where, as it's beginning to enter the Maritimes. So the tropical cyclone's pretty close to here, I imagine, right? Right in this area right here.
954.
Right, and so it's actually deepened from like 967 to 954 with this time period as it interacts with this wave. So what you guys were talking about earlier, Greg and John, about this interaction, this baroclitic interaction leading to this becoming more extratropical is probably consistent with the change in the structure of this cyclone. We'll go back to the PV maps for just a moment. And this is something that I don't know if it's an issue with the model or an issue with how they're actually calculating these maps, making these maps. You can see how smooth the colors look, and this is what I'm sort of more used to looking at. Back about 6 months ago, 3 to 6 months ago, the U.S. changed its global model. They're still running the older version of it over time. This is the same variable, and I'm not sure why it looks so messy. And maybe this is what it really looks like, but how it's fragmented.
Which is this, the older, this is the old one?
This is the new.
This is a new one. Oh, yeah.
This is the FD3. And I'm not really sure I fully appreciate why it looks this way and it doesn't have the smoothness. But I guess what turns out when you look at potential vorticity or variables related to it, the fact that it's very noisy right here, those small details really don't matter, because when you invert it, it really gives you the smoother wind field. Maybe this is the way it really should be looking, but it's just odd that we don't.
I suspect that's probably right.
Yeah.
I mean, I've noticed that on other maps too.
Right. Yeah, Brett.
So there's a couple things. One, I mean, the GFS is a spectral model, so vorticity is almost a normal, you're resolving
The word structural
your
vorticity.
features almost exactly. But then when they take the FV3, I think the FV3 model before you get it here
Mhm.
has been remapped to another grid.
Okay.
They take it back to a Gaussian grid, and it's not on its native grid.
Okay.
And I bet a lot of the noise and some of these higher order derivatives are because of that remap. But if you look, and we could check this, we could look at what potential participants look like on the native grid, and I bet it would be less noisy.
Yeah, that'd be something to look at, because I just noticed this, and it always makes me move back to the older version of the model with the GFS.
Yeah,
But the new one is finite element, isn't it?
yeah,
So it's not spectral.
no. And it's on a cube sphere, so it's on a,
But I would expect it to be somewhat more noisy if it's a finite element than a spectral, wouldn't it? But that may be real. I think that's why they went to the finite element, because the spectral smooths things too much.
when you used to, long time ago, when you looked at ECMWF versus GFS, when both were spectral, but one was a much higher resolution,
Yeah.
ECMWF always looked noisy too.
Okay. But I've seen the ECWF tropopause maps, these two PVU surfaces, and maybe they do some smoothing to clean it up, and they look more like the GFS one. And that, again, that could just be, what my eyes have become attuned to. But let's move away from the tropics for a moment. Well, actually, we're not gonna move away from tropics, because John loves the tropics. We'll look at the National Hurricane Center's outlook. So here's Dorian. We also have in the Atlantic Tropical Storm Gabrielle, and a couple other areas that they're watching over the next couple of days. I think the one that's located here, this disturbance right here, if we move the cursor here, you'll see a little bit of information on it. It's near the Cabo Verde Islands, some showers and thunderstorms. We'll look at a satellite image of that in just a second. They're saying little Finney development is expected until it moves a bit further to the west, in which it could begin developing. So they have a 70% chance of this, perhaps a tropical cyclone forming in the Atlantic due to this disturbance in the next 5 days or so. And it's this one which I think, once we look out in the forecast, it's about 2 weeks from now. It's about 2 weeks from any opportunity from impacting the continental United States if it does. But this is one that we probably want to bear watching. This one's expected to move toward the northwest. Has a much lower likelihood of intensifying, partly due to some of the shear caused by, I think, the outflow formerly the outflow from Dorian, but it's just not in a good environment at this point. Sea surface temperatures are pretty chilly off the African coast. They warm up rapidly. You go to the SIMS tropical cyclone page, which we don't have time to do today. They warm up to 28, 29 degrees Celsius. So this is going to be heading over water that's relatively warm. Very low vertical shear from that tropical cyclone page that SIMS has. And so this is something to bear watch, to watch for the next, probably next 2 weather watches we'll be talking about, something that emerges from this disturbance. Let's go back to the pivotal site. Please go to the surface map. We'll go to 6 hours into the forecast. And very quickly, just, this weekend looks to be a fairly nice one. And there's our hurricane. Here we are with weak northerly flow over us. Here are the thickness contours. The black contours are sea level pressure every 2 millibars or 2 hectopascals. These are in decameters, 564, 570, 560. These are a measure of the average temperature from 1,000 millibars to about 500 millibars. And the geostrophic thermal advection here is cold advection, so cooler air on average is being advected southward over us. If we go forward in time, let's just go to 18 hours in the forecast, so 1 o'clock tomorrow morning. That 564 contour hasn't really moved that far south. Broad area of higher pressure, this ridge that's beginning to build over us. So light northerly winds, and so this is going to be later tonight. Tomorrow we go to 30 hours. It's great, 24 hours. That 564 contours move further to the south, so the column on average above us has cooled off just a little bit. We'll look at the temperatures in a moment, but it looks like a nice day tomorrow. Maybe some clouds. There's a lot of precipitation out to our west, but we'll see that remains to our west at least through 48 to 60 hours. And here's the tropical cyclone beginning to re-intensify as it moves east of New England into the Canadian Maritimes. Let's go ahead to 1 o'clock Sunday morning. And you can see 564 contour that was up here earlier has been advected or is now located just along the Wisconsin-Illinois border. So cooler air is coming in, and again, still a nice evening, tomorrow evening into Sunday morning, and then we go to 48 hours just to go to Sunday morning. I'd say probably cloudy, but dry. So the weekend's going to be dry. For the game tomorrow, it should be pretty nice. Probably in the upper 60s or low 70s for high temperature, and lows over the weekend. Tonight and tomorrow night, probably getting into the 50s again.
Might be the score too, low 60s or 70s. We'll see.
So there's a ridge, there's a precip to our west, and we'll go ahead to 72 hours as we begin to knock that out. This ridge that was located initially over south central Canada has moved over to Ontario and Quebec, and we now see the ridge to our east, the southwest or southeasterly flow that begins to develop, or geostrophic flow begins to develop. And if we look at the dew points, let's look at temperatures first. So this is Monday morning. And we'll, in the morning we'll be around 60 degrees or so, mid-50s actually. And then if you look at the dew points, you'll see that all this moisture has been pulling up to our south. So this really, as this ridge continues to move toward the east, we're gonna see a flood of really moist air. It's gonna get more humid, feel stickier, or more uncomfortable perhaps as we move forward. Yeah. So let's go to 96 hours. This is Tuesday morning. Again, some showers. This cyclone that's developed in the northern Rockies has moved into northern Minnesota. Again, look at the temperatures early next week. So this is at 12Z. So instead of being in the 50s, like we're going to have this weekend, we're going to be in the 67 or so, and the dew points probably not that different. 66. So Tuesday morning is going to be kind of gross, but with that cyclone located over northern Minnesota, northwestern Minnesota, it's probably going to be, things are going to clear out probably by Thursday, or by Wednesday or Thursday. Let's go ahead to 120 hours. Maybe longer than that. Nope, that's not going to happen. Cyclone moves along, and we still have this broad darkness. We're still we're still south of the front, and so we're going to still be relatively warm. You can see the precipitation here. You can also see the trough, the pressure trough that extends to the east of this disturbance. Still going to be warm and still going to be humid. So that's Wednesday morning. 12Z is still going to be moist. I think it's actually Friday is when we're finally going to get our frontal passage. So let's go to 168 hours. Again, I guess we're going overtime. We're going way overtime. Sorry about that. 168 hours, so this is Friday morning. Finally, we get a nice frontal passage. This is the type of cyclone that Professor Martin likes.
Nice storm.
But look at this. We just look at things at 960 or so. This is 1,000.
Hey, you had to get resuscitated out off Cape Hatteras to get into the back into the 950s, thanks to the extra tropics.
True, but it got to the 960s
It did.
all by itself.
It did.
Without worrying about that.
All by its tropics.
1,004. So anyway, so the weekend looks pretty decent, but not. I don't think it's going to be bright blue skies and such, but it'll be cloudy, dry, and pleasant. And then it gets warmer and stickier by the time we get to early next week. And then it stays that way most of the week until we get this next frontal passage next Friday. Next Friday at Weather Watch, we'll have likely a guest Weather Watch leader, Chris Smallcomb from the National Weather Service office in Reno, Nevada, is going to be visiting with his family. And so we might have some much younger folks in the back of the room during that time period. But Chris was a graduate of our program back in the late 1990s. He got his bachelor's and master's degree here. And so, thank you, Professor John Martin, Professor Greg Tripoli, and Professor Brad Pierce for your contributions to this, and everyone for your questions and just your participation.
And
see
for
you next
Pete
week.
driving us
And
through
for
the whole
Pete,
thing,
certainly.
expertly as always.
Thanks, Joe.
Thanks.